Welcome to today's session, Accelerating Oracle Workloads on VMware Hybrid Clouds with VMware Performance Accelerators. My name is Sudhir Balasubramanian. I'm a Senior Staff Solution Architect at the Oracle Practice Lead for VMware. So let's get started. So this is the agenda for today's discussion. Essentially, we'll start with talking about some of the benefits of running Oracle workloads on a VMware vSphere platform. We'll follow that up by talking about persistent memory and how VMware vSphere is able to consume persistent memory and how we can use persistent memory to accelerate Oracle workloads. We'll talk a bit about RDMA technology and how we are able to provide para-virtualized RDMA drivers for virtual machine or for Oracle workloads running on a VMware vSphere platform, essentially using Oracle RAC as a use case for accelerating performance using PB RDMA. We'll talk a bit about the vSphere 1 gigabyte large page, talk a bit on some of the vSphere newer, the accelerators, right? 7.0 U3 accelerators, namely VMotion, the Assignable Hardware, and then wrap it up with a lot of collateral. Okay, so let's talk about, or let's take a look at some of the benefits of running Oracle workloads on a VMware vSphere platform. All right. And even before we look at the advantages of virtualization, let's first try to understand what Oracle BCA or business critical application these requirements are. And then let's understand the benefits of running these business critical Oracle workloads on a VMware vSphere platform. So any application, it doesn't necessarily have to be the Oracles or the SQLs or the Java or the SAP. So any application that is deemed business critical, they'll have certain SLAs, they'll have certain RTOs, they'll have certain RPOs. Essentially, what I'm trying to say here is they will have essentially a set of stringent requirements. So for example, the availability. Well, this particular application must be highly available. It must be resilient. It must be redundant. The fact that performance is of very utmost importance, right? So the timely process completion is critical. We must avoid all kinds of bottleneck. The fact that you are able to recover, but all kinds of disaster, you're able to scale up, you're able to scale out, you're able to add storage on the fly, you're able to add CPU on the fly, you're able to add memory on the fly. And the fact that security is of utmost importance. So these are some stringent requirements that any business critical application, typically Oracle workloads or SQL Server workloads, they have. And so there are many more benefits, not particular to any business critical vertical, that basically helps all workloads on a VMware vSphere platform. And we won't be able to go into all of them, but I do necessarily want to call some of them out. For example, resource maximization. Well, the fact that you have server resources, they increase too much for one application instance. By virtualizing, you are able to improve resource utilization, and hence you're able to reduce wastage. The very fact that you're able to provide, for example, enhanced availability. So for example, running Oracle RAC on VMware vSphere platform, that gives you the application level HA that Oracle RAC provides. And running it on VMware vSphere platform provides you the infrastructure level HA. Now, if I take the same configuration, and if I were to stretch that across metro distance, what I get is site level HA. So by simply running Oracle RAC on a VMware vSphere platform stretched across metro distance, I get 3 levels of HA: app level, infrastructure level, and site level. So there are many benefits of running the business critical workloads, SQL Server, Oracle, SAP, and so on and so forth on a VMware vSphere platform. All right. So let's take a look at the Oracle workload design methodology that's shown in the slide here, right? The overview, where essentially we start with the requirement gathering phase. We follow that up by selling the project to stakeholders, obviously for buy-in. And then we follow that by understanding the current environment constraints. We understand the database workload. We look at the various migration strategy, and that could include the big Indian to the little Indian migration as well. We understand the design considerations for high availability, for disaster recovery. We follow that up by backup and restore, or backup and recovery, by monitoring, by tuning, and last but not the least, Oracle licensing. So all of these are very important, a facet for any Oracle workload design methodology. But if we were to take a step back, and if you look at all these steps of the design workflow, there is no one step that is particular to an architecture, be that physical or be that virtual. So all we're trying to say here in the slide is there is absolutely no changes in the design methodology when one virtualizes Oracle workloads on a VMware vSphere platform, as opposed to running these workloads on a bare metal architecture. So Oracle workloads, They absolutely have no idea they're running on a virtualized platform. And the steps to provision, for example, the grid infrastructure, or let's say the steps to provision the RDBMS binaries, they're exactly the same as one would do on a physical architecture. Right. So this slide talks about the performance key best practices. Essentially, I wanted to hit some important points up here, right? So key thing to keep in mind, best practices needs to be inculcated into every layer of the stack, including the virtualization layer, to ensure that the workload can take advantage of the underlying stack. So for example, we won't have time to go into every one of those, but I do definitely want to call some out. So for example, making sure that we avoid any kind of memory and we avoid any kind of CPU overcommit, right? We design with NUMA in mind. We make sure that we use para-virtualized SCSI adapters, which means using SCSI adapters, virtual SCSI adapters on rocket fuel, which makes the workload, the IO, the workload IO go very fast, making sure that we distribute the Oracle VMDKs or the virtual disk when it comes to the operating system, the binary, the data, the read log files across all 4 PV SCSI controllers, making sure that we use the same para virtualized adapters when it comes to networking and so on and so forth. So the link at the bottom of the slide goes into every tenet of best practice when it comes to all of the 4 quadrants, the CPU, the memory, the disk, and the network. All right. So let's take a look at this slide, right, for a second here, right? So as we can see, processors, they're getting faster, right? Caches are getting bigger and bigger. NUMA awareness is better. And hypervisors are getting smarter by the day. And of course, storage is getting faster. So putting all of these together, all of these factors, it makes it a perfect scenario, right, for virtualizing most of any applications. So we can see with every version of VMware vSphere, right, we have been increasing the performance and we have been increasing the scalability by leaps and bounds. So essentially, as we can see, our journey started with the ESXi1 all the way till 7.0 U3. And I'm missing a column here at the end, should update the slide. But that's the latest release when it comes to VMware vSphere platform. But we have been increasing our performance and scalability by leaps and bounds. So any lingering performance concern that anyone has, right, relating to VMware, the platform per se, or relating to VMware virtual machines, that is clearly due to a lagging perception from very early generation, which I accept, right? I have some limited capabilities, right? And then the link at the bottom of the slide that basically talks about the configuration maximum, which means, what is the maximum configuration that one could have with respect to CPU, memory, disk, and network when we start talking about virtual machines on a VMware vSphere platform. So I'm going to move to the next slide to show what the config maximums are. And on a VMware vSphere platform, right, 7.x, the configuration maximum, if you look at it, right, this slide talks about the 7.x config maximum when it comes to the compute, the storage, the memory, and the network, right? And these are the maximums that a virtual machine can address on the current 7.x platform, right? And as we can see, we can go to a max of 768 vCPUs, which means virtual CPUs that a virtual machine can address. With respect to memory, a virtual machine is able to address up to 24 terabyte of VRAM. You're able to add a NVMe controller, and that's where we talk about persistent memory in the coming slides, right? The fact that you have up to 4 para-virtualized SCSI controllers or 4 virtual SCSI adapters, and you can have them as a PV SCSI type as well. And the fact that every PV SCSI adapter can have 64 targets or 64 virtual devices, and one does the math, you have a total of 256 VMDKs. And the fact that every VMDK or every virtual disk can go to a max of 62 terabyte, you guys can do the math. 256 times 62 TB. That's the amount of space, storage space, that a virtual machine on VMware vSphere 7.x can address. And let me move to the next slide, which shows actually these numbers in perspective. All right. Monster virtual machines, right? We used to call big VMs monster virtual machines. And there was even, I think, a VMworld session where there were a couple of VMworld sessions where there was someone in a monster VM costume. I think, I don't remember the exact year, but there was somebody in the crowd who basically had a monster VM costume, right? Given that the maximums are so much larger now, I don't know what we call these, right? For example, I spoke about the fact that every VM can address up to 25 terabytes of VRAM. That should be good enough for anybody, yeah? So it's also worth noting 2 things. First, that the website, and that's up in the title here, in the subtitle here, that's a site where we have config maximums now, right? All of the config maximums can be found there. I already spoke about that in the previous slide. Second, VMware vSphere 7, right, 7.x, that basically has the virtual machine hardware 17, 18, and now we have 19, right? And there is a new virtual hardware you can add that requires these versions, right? So what happens is the upgrade process from the older hardware version to the newer version, that's very easy if you have older virtual machines, right? You just have to schedule the VM compatibility or the VM hardware upgrade in the web client, so that next time that the guest operating system comes up, right, it's able to upgrade or update the hardware version. So we always recommend that, right? We always recommend saying, take advantage of the newest and the latest and the greatest hardware. So that way you are able to make use of all of the latest and the greatest features that this platform, the current platform, has to offer. All right. So VMware announced the general availability of 6.5. That was in 2016. We announced 6.7 in 2018, and there were a lot of features, right? They were released as part of the 2 announcement, right? And some of the notable features here, we came up with the virtual hardware, VM hardware level 13. We came up with the fact that now you're able to provide 4 adapters of virtual NVMe controllers with 15 targets each. The fact that we onset persistent memory. So it was that release, the 6.5 release, where we were able to use PMEM or persistent memory with VMware vSphere platform. The fact that you're able to that we were able to come up with the para-virtualized RDMA drivers and the support for 512E drive support, right? 6.7 notable feature that came out was the 1 GB large pages, and the fact that we had 4K local storage support, and the persistent memory feature was actually honed. It was actually honed, and was actually made much improved in 6.7. And we will definitely have a look at the persistent memory in the forthcoming slide, but moving on. All right. So with the release of vSphere 7.0 on April, and that was 2020, last year, right? There were a lot of features that were added. I mean, we won't have time to go into each and every one of them, but I do definitely want to call some of the notables one out for business critical application workloads, namely the improved distributed resource scheduler, DRS as we fondly call it, the assignable hardware, refactored VMotion, and the fact that you have intrinsic security, you have vSphere Lifecycle Manager, and VMware vSphere Now with Kubernetes. So the link at the bottom of the slide, both of the links essentially talks about all of the features that were released, all of the resource management capabilities. All right. So moving on to VMware vSphere persistent memory. Okay. So let's take a look at this slide here, right? If we take a look at the pyramid on this slide, that pyramid shows the convergence of memory and storage, right? So at the top of the pyramid, the technology that is characterized by shortest latency, the best performance, right? It has a higher cost related to the items at the bottom of the pyramid, right? So these essentially are the technology layers that comprised of DRAM, memory, right? And the CPU, cache, and the registers. And all of these components are accessed directly by the application. I mean, they're also known as the load storage access, right? Now, look at the bottom of the slide here, or look at the bottom of the pyramid here, sorry. It is characterized by longer latency, lower cost related to the technology, right? At the top of the pyramid. These technology components, they have block access. What that means is data is typically communicated in blocks of data and the applications are not accessed directly, right? So the PMEM or the non-volatile memory, the NVM, this layer sits between the NAND flash and the DRAM, providing faster performance relative to NAND flash, but that also provides the non-volatility, which is typically not found in traditional memory offerings. So this technology layer provides the performance of memory with the persistence of traditional storage, and hence the name persistent memory, right? So it's persistent and it has memory-like latency and memory-like characteristics, right? So with the introduction of this new category called persistent memory, we essentially are straddling these two domains, right? The domain up at the top, the domain up at the bottom of the pyramid, right? So what we can do with persistent memory is applications can access PMEM or persistent memory just like DRAM over the DDR bus with load store instructions. The data is byte accessible, which means your latency right now is in nanoseconds versus microseconds, right? So you have DRAM-like latency, you have DRAM-like bandwidth, right? And persistent memory that offers greater capacity points, lower cost compared to the DRAM, right? And the persistent memory uses a non-volatile memory technology. So if the power were to get lost, right, the data were to persist. So there is no loss in data, right? And the link at the bottom of the slide was the initial study or the initial use cases that we did with Micron PMM. So there is an ongoing project with Intel as well, right? And I'm going to go to the next slide that talks about some of the use cases we did with the Micron PMM technology way back up in 6.7. So even before that, right? Let's talk about how the Intel Optane PMM, before I come to the how the PMM can be consumed, right? How Intel Optane PMM that benefits the VMware vSphere user, and how is VMware vSphere platform able to consume the persistent memory, right? So essentially, the Optane PMM or the DC Optane PMM is configured in one of the two modes, right? It can either be in what's called the app direct mode, or you can use that in the memory mode. Yes, there is a third mode also called as the mixed mode, right? Where some of the capacity is for memory mode and some for the app direct mode, but we really don't see a lot of customers, right, come up with a good use case for the mixed mode. So essentially we see customers coming up with, use cases for the app direct or the memory mode, right? So talking about the memory mode first. In memory mode, the installed the Intel, the Optane memory, the PMM modules, right? They act as the main system memory, and the DRAM capacity becomes an extra level of cache. So what happens is the CPU memory controller that manages the PMM capacity, which means OS or the operating system has no direct access to the PMM, right? So memory mode, what are the use cases? Memory mode works very well in situations where the application working set, it fits within the DRAM size, but more capacity is needed to avoid any kind of paging from disk. So if we need to have virtual machines, or if we need to have servers, right, which requires large DRAM capacity or capability, memory mode is the way to go, right? Now, the second level of the way that you can consume persistent memory is the app direct mode. Here, what happens is the PMM capacity or the persistent memory capacity that is exposed to the operating system as an additional memory tier. So what happens is the namespace type determines how the OS exposes the PMM to the application. So for example, you have four namespace types. You could either configure that in the FSDAX mode or the DevDAX, or you have the sector mode, or you have the raw mode, right? And FSDAX is the default and the recommended namespace type for most situations. So the next slide will get into how VMware vSphere is able to use, right, persistent memory, and what are the different modes VMware vSphere is able to provide persistent memory capability for virtual machine or for workloads. Okay, so VMware vSphere, right? We expose the volatile DRAM to virtual machines, and the memory scheduler manages that, right? And if you look at the left-hand side, we have all the devices or all the disk, right? And then we have the virtual disk that is attached to the virtual machine via SCSI emulation or NVMe. Now, the new device that borrows property from both the memory side and the disk side, that's the persistent memory. So essentially what happens is we build the persistent memory data store, right? Or any kind of region store in the VMware vSphere VM kernel. And that manages the Intel Optane PMM, right? That allocates the PMM regions, and that can be attached to the virtual machine. Now we need to look and see how we can expose that to the virtual machine. So there are two ways you can do it. For legacy operating system, for legacy applications which are not DAX aware, right? We can expose the persistent memory as a block store, right? Essentially as PMM disk. So what happens is ESXi or VMware vSphere consumes the persistent memory, right? And basically creates a data store. And then you're able to put your virtual disk or your VMDK for the virtual machine on these data. So the data is on the Intel Optane PMM. So it's an ultra fast disk. The best part is there is no guest operating system changes. Simply by storage VMotion or by moving your VMDK or the virtual disk to that data store, to that persistent memory backed data store, you are able to accelerate the workload. You're able to take advantage of persistent memory. Now, on the flip side, right, when we start looking at modern operating system, right, be that RHEL, be that OEL, you are able to expose persistent memory as an NVDIMM, as a virtual NVDIMM device onto the virtual machine, onto the guest operating system, and then you can then expose it as byte addressable, which means you're able to mount it, right? So you can use the mount -O DAX option. You're able to mount it so it's byte addressable. So in this way, you are able to bypass the kernel cache, right? So there is no double buffering. You're able to bypass the kernel cache. It's a direct write. You're able to address those memory sectors, right? And those are 8 KB atomicity. You're able to, 8-byte atomicity. You're able to address that, right, directly. So that's the advantage of using the byte addressable, persistent memory in a DAX mode. Right. So with 6.7, this paper was done with 6.7, right? Essentially, some of the use cases we ran was to accelerate the performance of Oracle redo log activity. And as you guys are all Oracle experts, you guys, everybody understands, by improving the performance of the Oracle redo log activity, we're able to improve the overall database performance. The second use case that we came up with was accelerating performance using the Oracle database Smart Flash, right? And as everybody on the call understands, the session understands, the Oracle primary cache is called the buffer cache, right? The Smart Flash cache is the secondary cache. So anytime blocks get evicted from the buffer cache, that gets destaged to the Smart Flash cache. And if needed, those blocks are reread from the Smart Flash cache into the buffer cache. So there is no need to really go down to the disk to read it, right? So we were able to then, use persistent memory for the Oracle database Smart Flash cache, which means we were able to accelerate the performance of any blocks that basically gets decached from buffer cache over to the secondary cache, right? And last but not the least, we did see a potential reduction in Oracle licensing. Again, this session is not to talk about Oracle licensing, but again, please do have a look at the paper. The link is there in the bottom of the slide, right? That talks about the use cases with Micron PMM in more details. And as I mentioned in the previous slides, we have ongoing collaboration with Intel on Intel DC Optane PMM to work on the above use cases and much more. Moving on. All right. So prior to vSphere 7 update 3, the memory statistics were not easily accessible without installing additional third-party command line tools, right? Starting with vSphere 7.0 U3, which is our latest and the greatest update that was released in VMworld 2021, right? They are now built directly into VMware vSphere, right? And they are visible in the UI as well. So this enables troubleshooting. This enables monitoring of memory bottlenecks, right, between normal system DRAM and persistent memory, Optane and the NVDIMMs, right, at both the host and the VM levels. So this is supported on, I think, Cascade Lake and also on Ice Lake families on Intel CPUs, and there's a compatibility matrix for this feature. All right, switching gears and talking about VMware vSphere RDMA and para-virtualized RDMA technology. Right. So as all of us, we know, right, RDMA, well, that's a hardware transfer protocol. Essentially, it's optimized for moving data to and from memory. Advantages of RDMA or the remote direct memory access. It's an OS bypass, it's zero copy, low latency, high bandwidth. So what are some of the use cases that can come to our mind? That could be mission critical Oracle rack, right? By using RDMA technology to accelerate the cache fusion traffic for the Oracle rack private interconnect, that basically accelerates the performance of the Oracle cluster per se, right? The second use case could be distributed databases, right? Third could be the big data. Fourth is, any kind of storage, right? Or any kind of HPC, right? When we use MPI or SHMEP. All right. So we all know that the Oracle Cluster Interconnect Protocol, that was developed by Oracle and QLogic, right? Long time ago. That was done specifically for Oracle Rack. And that was called RDS, the Reliable Datagram Sockets, right? And that RDS, or the Reliable Datagram Sockets, is completely agnostic to the underlying RDMA, right? Capable devices, and it simplifies implementation. So the RDS protocol that can work either over an RDMA capable Ethernet network interface, a NIC card, or that can go over an InfiniBand HCA, the host channel adapter, right? And as I mentioned before, RDS, that is an offload driver, right? That's basically an IPC protocol with low overhead. It's got low latency, high bandwidth. It frees up the CPU cycle so that CPU cycle could be used for application processing. It's completely agnostic to RDMA capable devices. And it could work either over an RDMA capable Ethernet NIC, any of the Rocky cards, or it could be over an InfiniBand HCA. And the Oracle workload acceleration with PV RDMA use cases, this is an ongoing project. This is in progress. Hopefully by the end of the year, we should have some collateral released on that. And the first use case was using Oracle Rack with PV RDMA, so essentially using the UDP default protocol for Oracle Rack and clusterware, to measuring the workloads, and then using RDS with VMware PV RDMA. So far, the results have been very promising. So stay tuned, and definitely stay tuned for the collateral. Hopefully, we release that by the end of the year. But moving on to VMware vSphere 1 gig huge pages. All right. So, we are all familiar with huge page feature, right? And essentially, the huge page feature is a feature in Linux which makes it possible for the operating system to support memory pages greater than the default 4K, right? So by using these very large or huge page sizes, that can improve system performance by reducing the amount of system resources required to access PTE or the page table entries, right? So, the huge page size, they vary from 2 megabyte to 256 megabyte, depending upon the kernel version and the hardware architecture, right? So advantages, huge pages, which everybody on the session is aware of. The pages are locked in memory. They never get swapped out, right? That provides RAM for the shared memory sectors, right? For example, the Oracle SG, right? So contiguous pages are pre-allocated, and it's only used for the system file shared memories. Oracle SG is an example here. And it is less bookkeeping for the kernel, right? So you have a lot of TLB hits, right, by using huge pages as opposed to not using huge pages. And everybody is aware, AMM, or the automatic memory management, and the huge pages, they're not compatible with each other. All right. So these are results from a series of tests that we conducted, right? Where we ran the TPCC-like benchmark, the slob load generator against an Oracle database on a VMware vSphere, right? We did that with and without the guest operating system 2 megabyte huge pages, and the results are shown in the slide here, right? So in this case, where we did not use the huge pages, and that's to the left of the slide, if you look at the value of the page table entry in the /proc/meminfo output, we can see there is a gradual increase of the number of PTE or page table entries as the workload runs. This means that the huge page is not set up here. And on the right-hand side, with the huge page setup, the PTE or the page table entry becomes static after reaching a steady state. So there are a lot of advantages here using huge pages, right? And everybody is aware of it. So moving on to the next slide, where we talk about the 1 gigabyte huge page for Oracle workloads, right? And these are some of the requirements, right? So starting with VMware vSphere 6.7, the 1 gigabyte huge page support that was provided for VMware for the virtual machines VRAM, virtual RAM, right? And it had a bunch of caveats. It had a couple of caveats, I would say, right? That basically the virtual machine had to have full memory reservation, along with the fact that the 1 gigabyte page VRAM backing, well, that's opportunistic, right? And the 1 gigabyte pages are allocated on the best effort level possible, right? Red Hat RHEL 6.7 systems and onwards, they support 2 MB and 1 GB huge pages, which can either be allocated at boot time or runtime. Right. So from a VMware vSphere perspective, we are able to provide the 1 gigabyte huge page capability. As I mentioned before, RHEL 6.7 and above, they are able to take advantage and able to provide support for 1 gigabyte huge page. Now the question is, can Oracle take advantage of this 1 gigabyte huge page support? And as we did as a series of tests, unfortunately, right, as a test result pointed out, there's an unpublished bug here, 172.71305, as shown in the slide here. The issue is in the Oracle code, right? So ideally, the fixed SJ would be in 2 megabyte huge pages. I mean, it's small enough to fit into a 2 MB huge page. But then in order to use the 1 gigabyte huge page, that requires additional changes to the Oracle code. So there's a blog at the bottom of the slide, and that talks about the findings, right? And it talks, it talks about the findings, what we got from using 1 gigabyte huge page for Oracle workloads on a VMware vSphere environment, right? But moving on. Okay. So having spoken about persistent memory, we spoke about PB RDMA drivers on VMware vSphere platform. We spoke about the 1 gigabyte huge page support on VMware vSphere platform. Let's shift gears and talk about the vSphere 7.x, essentially 7.0, U1, U2, U3, new features and the new accelerators they were released as part of those releases. And what are the benefits of using those for the Oracle workloads on a VMware vSphere platform? Okay. So talking about VMotion, and everybody is aware of what VMotion is. Essentially it's essentially the process of moving the compute, right? The compute, which means the compute of a virtual machine. So the memory and the vCPUs of a virtual machine from one ESXi host to another ESXi host in the vSphere cluster without any downtime, without any disconnect, without any breach of SLAs, right? So speaking of VMotion, well, that has been tremendously reworked in 7.1, version 7.1, right? I mean, every feature in VMware vSphere has been has been worked on to mitigate risk in one way or the other, right? So going back to VMotion in question here, right? VMotion, it uses what's called a page tracer to help copy memory from source host to the target host. So the way VMotion was used was to install a page tracer on each vCPU on a virtual machine, right? That seemed like a good idea at that point of time. But then what used to happen was it would compete with the workload itself for CPU cycles, and that everything would slow down. What then we did was in 7.0, right, we completely changed it. Right? We said, okay, let's claim one vCPU to do all of the memory copying work, leaving the rest of the vCPUs free to do the actual work, the workload, right? And this was much more efficient. The guest operating system is much more tolerant of one CPU seeming slower than the other, right? Because remember, this is all behind the scenes, right? This is something that the guest operating system doesn't know what's happening to it. We also, what we did was we optimized the final switchover. So when the virtual machine is temporarily stunned, and the stun period is like a couple of seconds, right? So that the final bits of memory, the delta memory, can be copied over. So this stun time was noticeable, but with 7.x, we completely brought the stun time to like very, very, very low. So 7.x, vSphere 7.x, that brings better support for fast modern networks, so that vSphere admins, they don't have to do any kind of tuning for their VMotion anymore. And the best part is, we heard a lot of positive feedback from our customer base, from our customer community, especially with real time and with critical workloads. So this is a great release. This is a great feature and a great benefit for Oracle workloads, for latency sensitive Oracle workloads. All right, DRS, the Distributed Resource Scheduler, or DRS. Essentially, that is a core piece of VMware vSphere, right? And what it does is it moves the workloads around so they make best use of the compute resource available to them, right? In the previous version, before 7, what VMware vSphere, the DRS used to do, it used to focus on what's called the cluster state, which means it used to check and see if it needed any kind of rebalancing, because it could happen, right? At some point of time, you have one ESXi server overconsumed, while you have another ESXi server with less resources, right? And if the DRS logic determined that, yes, it could improve the cluster balance, it would recommend and execute a VMotion, right? Depending upon the configured settings. And that way, the DRS is to achieve the cluster balance by using a cluster-wide standard deviation model, right? With vSphere 7, the new DRS logic takes a completely different approach. It computes what's called a VM DRS core on the host, and it moves the virtual machine to a host that provides the highest VM DRS score, right? Here, what we're doing is we are improving the workload balancing on the cluster by focusing on the metric that we really care about the most, the virtual machine happiness, right? So this was a tremendous improvement in the DRS technology, in the DRS, the logic, right? And by doing it, right, again, our customer base, absolutely ecstatic. They are very happy with this because we are able to provide something that everybody cares about the most, the virtual machine, the workload happiness. Moving on to what's called assignable hardware, right? And everybody has heard of GPUs, right? I mean, that's the new kid. That's not the new kid in the block. I mean, that's something that's actually new, came out a couple of years, and everybody's using GPUs, right? So the new dynamic direct path IO and NVIDIA GPU, right? vGPU, they are both using what's called the assignable hardware framework, right? So the direct path IO, that's a new way of configuring pass-through to expose PCIe devices directly to the virtual machine, right? And what happens is no longer is the hardware address of a PCIe directly mapped to the configuration file of a virtual machine, which is the .bmx file, by the way, right? But what we do is we expose a PCIe device capability to the virtual machine. So for example, you have a virtual machine, that virtual machine needs a GPU of, let's say, V100, correct? So the assignable hardware, the technology, that will now interact with DRS to find an ESXi host that has a device available. And then what it will do is it will claim the device, it will register the virtual machine to the host, and then when the VM is vGPU enabled, DRS will then is capable of finding that ESXi host that has the same GPU profile available, right? Okay. NVMe over TCP, over Fabric TCP, right? So NVMe over Fabric, that extends the NVMe from any local storage, right, to shared network storage. And with release 7.0 U3, right, the supported protocol, I mean, in fact, so with the previous versions of 7.0, which is U1 and U2, the supported protocols for NVMe over Fabric, they were fiber channel and they were RDMA. With 7.0 U3, the latest and the greatest version, which was released a month ago, VMworld 2021, we then added support for NVMe over TCP. So one of the benefits of using NVMe over Fabric TCP is that there is no need for any kind of specialized HBAs. You don't need any kind of RNICs for connectivity, right? So any standard Ethernet networks, hardware, it could be used. Of course, having the necessary bandwidth for the additional overhead, that's imperative. So with the ability to use standard network hardware, the cost of entry for the NVMe over Fabric TCP, that's a lot less than either Fabric channel or with RDMA. And so this is now allowing many existing customers to get access to the newer storage technology like NVMe over Fabric, right? So this was one storage, or this was one core storage enhancement that came out in 7.0 update 3, right? There were a lot of enhancements that came out. The other notable one that I really want to call out is with vVol batch snapshots, right? With virtual volumes, right? We are able to help with the scalability of vVols, right? We enhance this procedure for, let's say, processing large number of vVol snapshots by making these vVol snapshot operations into a batch process. So, I mean, we could go, a lot more detail into that, time permitting, but there have been a lot of features that were released with 7.0 U1, U2, U3 with respect to the compute, the memory, the network, and the storage quadrants. So moving on. So as part of the wrap up, I'm going to move on to the next slide here, right? Essentially, anything and everything Oracle on VMware vSphere, right? Whatever the white paper it is, whether it's Oracle on VMware, VMFS file system, or whether that's with the vSAN technology, whether that's with virtual volumes, or whether that's Oracle on any of our VMware cloud offerings, be that Oracle on VMware Cloud on AWS or GCP, OCVS, AVS, any best practices guide, deployment guides, any kind of workload characterization guides, business continuity guide, Oracle Rack on a VMware vSphere platform. Pretty much everything and anything can be found in this one-stop shop. This is truly a one-stop shop. So essentially, this is a blog that was created in 2017, but that's an active blog, and I keep updating that with with any time we produce a collateral, be that a blog or be that a white paper or be that a KB article that is pertinent to the running Oracle workloads on a VMware vSphere platform. So please do bookmark it, and please do refer to it anytime you have a question. But moving on, this is a bit about me. Okay. And thank you for attending today's session. We hope that you found that useful. So again, please, post your questions in the question and answer box, or if you have to come out of mute, so be it, right? And I think the session recording will be made available to you after the event. So again, if you need any information, you can always reach out to me via the Twitter handle, right? And with that, thank you for your time today. Yep, a couple of important dates. If you could please bookmark it. And the session survey. So please complete the session survey for this session using the Zoom session survey link. That link will be provided via email once the webinar is closed. But thank you for your time today, and thank you for listening.